Okay, let's move into translations and reflections. And so this can get a little bit complicated when we're talking about them. The first thing that we're going to deal with is we're going to deal with translations. And translations are how the function moves up or down, left or right, goes up faster, goes up slower. But I want to explain it not in terms of the functions that we're using right now because it can get kind of confusing. But instead, what I want to do is I want to do it with an absolute value function, which is going to be the next section that we're going to get into anyway. So I want to show you how that's all done. So if I go over here and I go to Desmos, so remember that using Desmos, you're allowed to do, and I want to make sure that you use it as a tool. We're going to do f of x equals, and then I'm going to do this little thing here that looks like these straight lines. That's what is known as a vertical bar. That vertical bar is located, if you look at your enter key on your keyboard, right above it, you'll see the enter bar is in the upper position above the backslash. So you'll see that over there. That's how you type in absolute value. So you don't need to worry about what the absolute value function is. I just want to show you what happens. So first thing is that we're going to look at this particular function. Notice that there's a point here called the vertex, which we'll identify again next time. You don't have to know all these terms right now. We're going to learn them all more in the next section, but I have to point some of these things out because of what we're doing here. So here is my absolute value function graphed. It looks like two lines. It looks like a V. There's certain characteristics about it that we'll talk about next time. We've talked about the absolute value function before, just not moving it around. Now, what happens when I add something outside of the absolute value? So if I add 2, notice what happens is that function shifted up. So it went up 2. So when I add a number to the outside, that's going to cause the absolute value function to move up. Now we're always looking at the origin point, this point right here, not looking at any of these other points, even though they all shifted up 2. This one's the easiest one to identify. So if I do +1, now if I do +3, and now if I go negative, notice that it goes down. So anything outside causes it to go up or down depending on the sign. So if it's positive, it goes up. If it's negative, it goes down. Okay, so that's one thing. So another way that we move things around is if we put a number inside with the x. So if I put a -2 here, or a +2, which is what we did last time, if I put a +2, notice that what happened was it didn't move to the right, but it moved to the left -2. So any number that I put inside here, adding or subtracting, is going to cause the function to shift in the opposite direction. So when I put a +2, it shifts to the left. When I put a -2, it shifts to the right. So we can kind of see what's happening with that one. If I put a -5, you can see that it shifted 5 to the right. And now if I add some things, now notice here, this one went 5 to the right because of this -5. And if I do a +2, notice not only did it move 5 to the right, but it moved up 2. And you can see that the vertex did exactly what I just said it did. Remember that this is the x value, this is the y value, so this moved 5 to the right and 2 up. If I move to the left and I look at that point again, so you'll notice it moved -5 because -5 is to the left and +2, so -5, +2. Okay, and that's the way it's always going to work on those kinds of shifting. So that's the first part. That's this k value over here. So if I'm adding anything outside of the function, it causes it to go up or down. If I add anything inside the function, it causes it to go right or left. Okay, and of course it's opposite of what you would be thinking of normally when we start doing it. So notice k moves the function up or down, and we haven't talked about the other ones yet in this particular case. And by the way, these are wrong here. So this should be a 1 and this should be a 1. So if I were to go in here, I would change those both to a 1, and that one is to a 1. So when it's over 1, okay? And then we're going to talk about these stretches. So we can see what's happening with k. Now we want to do is see, and with any other values inside. Now we're going to look at what happens when we do a multiplier. So notice I move this around. I'm going to go ahead and move it back to the center. Now move back to 0, 0, which is where that is. That's located. And now what I'm going to do is I'm going to put a number out front. So notice if I put a 3 out front, excuse me. Actually, let me do a 4. Okay, so if I put a 4 out front, and I'll show you why I did a 4. So when I put a 4 out front, notice this didn't shift because we didn't put a plus on the outside, but it did go up faster. And in reality, it actually went up 4 times faster. So now what I'm going to do is I'm going to plot the other one. So I'm going to do f of x equals the absolute value of x so that we can compare them. I'm going to change this one to black. And so you'll notice here is what is called the parent function, right? So that's the original function. That's this second one. You can see that that one's black, this one's red. So in this particular case, when we go 4 up, notice that our next point that we can see, or actually when we move over 1, we go up 1, right, on this one right here, because the slope is the number that's in front of it. So we go over 1, up 1. Now notice in this case, we go a little different. We go up 4 and over 1. So notice if I go up 4 and over 1 on each side, you'll see that those points actually cross right there. And I can kind of get them in there. This is a little hard there. It is 1, 4. And you'll see that we should have negative 1, 4. Oops. There you go, negative 1, 4 there. Okay, so that tells me if I go to the right one, or if I go up 4, I go to the right one and to the left one, because that's the way the function works. But this is called a multiplier. It makes it go up faster. Now notice what happens if I make it go up slower. So if I do 1/2, not negative, but if I do 1/2, notice that it stretches out. So it kind of creates a wider V as opposed to a more compressed V. So that's what's happening in this particular case. So if the number, so what it's kind of saying in this particular one right here is it says A causes it to vertically stretch. So if A is greater than 1, that means it goes up faster. Or it shrinks if the number is between 0 and 1. So if the A value is between 0 and 1, then that means it's going to shrink, or it's not going to stretch. It's actually going to do the opposite of stretching. It's what is known as compressing, and that's what's happening. So those are the terminologies that you have to understand. So it's just good because these particular problems have this kind of thing that happens. It'll make more sense in the next section too. We're going to be dealing with this part a lot more. And then if A is negative, so notice here we have all these values. So what I'm going to do is I'm going to get rid of this 1/2. Okay, so now both of the functions are the same. That's why we only see one thing here. Okay, so notice here, if I put in a negative, notice that the absolute value function that's black here is actually still going up. But this one is actually what is known as started going down. So notice that you can kind of pretend that there's a mirror going across this x-axis. And so if you look at this, and then you look across the mirror, in the mirror, this thing looks exactly the same, just it's going down as opposed to going up. So that's what the negative does outside. Now, what does the negative do on the inside? So just want to point out one more thing. So the negative causes it to flip over. So I'm for now going to get rid of this. Watch this. If I go up here and I get rid of the negative, there's the original. If I put in the negative, it's flipping over the x-axis. And now you'll notice something else. When I go inside with the x, notice where the x is now. I'm going to hit negative, and it doesn't change. Well, to you, in terms of looking at it, it doesn't change, but it actually did change. So I'm going to show you why. So what we're going to do is we're going to move it. So let's go ahead and move this function to the right 2. So if I want to go to the right 2, I'm going to subtract 2. Remember, if I'm going to the right or left, I do the opposite. So I'm going to subtract 2. Now I'm going to put a negative in front of here. So watch this. So actually, put parentheses around this, and the only reason is because I want to show you what happens. It's the same thing. Nothing has changed. Just kind of messed up here. Okay, there we go. So notice I just put parentheses because I want to show you how the change actually works. So notice I did x minus 2. I'm going to put a minus in front of that. Okay, so if I put a minus in front of that, did that switch around? No, but it should have. And let me show you what happens, because I know what I forgot. So notice here, if I put if there it is, x minus 2, if I stick a negative in front of the x, notice what it did is it actually shifted around the y-axis. So this is the y-axis. It's a little harder to see, but notice that this 2 went to negative 2. And so you can kind of see what's happening with that negative in there. Just know it to a certain extent here. We're going to learn it more in the next lesson, not this one. This one's kind of just because some of the problems do that. You need to know, but don't stress out if it's not making a whole lot of sense yet. Okay, and I think at that point we've gone through all the dilations. So if A is negative, it reflects over the horizontal line. If B is negative, so if the number inside the function, so that's where the b is supposed to be, is right inside of that function there, then it reflects over the vertical line. So that's really what's happening in those cases. Okay, we're going to do some examples in the next videos and show you how it works.